Okay, for topic two, we're going to talk about evaluating expressions with integers. We've already introduced very gently the idea of algebra. That's where we have variables that we can replace with numbers, and we can do something called evaluating, which just means simplify if the variable equals a particular number. Okay, so looking at example two, it says replace all variables with given values and then simplify. So we have these algebraic expressions. We're told to replace each variable with a certain number, and then we're just going to use the order of operations to simplify from there. So for part A, we have -3 times x times y. So if you see just -3 and then an x and a y right beside, the multiplication is assumed. So that would indicate multiplication here. I'm going to rewrite this expression. Anywhere I see an x, I'm going to replace it with -4. Anywhere I see a y, I'm going to replace it with -2, and then I'm going to simplify. So this is going to equal -3 times x, which is -4, and then times y, which is 2. So what we're doing here is we're multiplying a series of integers. And when you multiply a series of integers, you always want to count the negatives, okay? So we have an even number of negatives. We have two negatives, that's an even number. And if you have an even number of negatives, that tells you you are going to get a positive product, okay? So we're going to get a positive product. This is going to be positive something. But what is that something? We just multiply these values. So 3 times 4 is 12, and then 12 times 2 is 24, and we already know this is positive. So our final answer is positive 24. Okay, for part B, we have -2x, so that just means -2 times x. And then when you have a fraction like this, that fraction bar just means divide. So this is 2 times x divided by y. I'm going to evaluate for x equals -15 and y equals -6. So this is going to equal -2 times -15, and then I'm going to do the fraction bar, which we know just means divide, and we're going to replace y with -6. So what I'm going to do is I'm going to completely simplify my numerator first, and then I'll divide the numerator by the denominator. And just remember, numerator is the top number in a fraction, denominator is the bottom number in a fraction. So for the numerator, I have -2 times -15. When you multiply two numbers with the same sign, the product is always positive. Even though these two numbers are negative, the product is going to be positive. So 2 times 15 is 30, and we're going to keep that positive, and then we're going to divide that by -6. Now, when you divide two numbers that have different signs, your product, or quotient in this case, is going to be negative. So 30 divided by -6 is going to be -5. And that's it. You know you're done when you've evaluated, you've replaced all the variables with some given value, and you've simplified it completely to a single value. All right, part C. We have a wacky one here. So for part C, we have negative absolute value of x minus 5. Well, that negative in front of the absolute value can be thought of as multiplying the absolute value by a -1. So I could just right off the bat rewrite this as -1 times the absolute value of x minus 5. I'm going to make that look like a 1 really clearly. Okay? Now what I can do is I can evaluate the absolute value part for when x is 4. So I still have my -1 times, and then for the absolute value, I now have 4 minus 5. So let's see what that gives us. So off to the side, if you need to, 4 minus 5 is pretty easy. Most of us can do that in our head. But if not, just remember, we keep the first number the same. Instead of subtracting +5, I want to do the opposite of both of those. So I want to add -5. And then when you add two numbers with different signs, you want to find the difference between the positive and the negative. So the difference between 5 and 4 is 1. And because I have 5 negatives but only 4 positives, that tells me that negative is going to follow through to my answer. So this is going to be -1. So what we have over here on the left is -1 times the absolute value of -1. And when you're dealing with absolute value, it can sometimes be helpful to think of a number line. So remember, absolute value is always a number's distance from 0. So we say the absolute value is always positive unless there's a negative in front, because even though -1 is to the left of 0, it's still only 1 unit away from 0. So the absolute value of -1 is just 1. So what we have here is -1, the negative from the outside, and then we have just +1 for the absolute value of x minus 5. And that tells me at the end of the day, my final result is -1. So that one's a little bit tricky. So make sure you watch this video more than once if you need to. All right, part D, we have negative square root of x plus y. So notice we've got that negative out front again. So I'm going to treat that like a -1 times the square root of x plus 5. And we're told to evaluate for when x is 16 and y is 9. So let's see how this looks. I'm going to treat that negative like a -1 times the square root of x plus y. So that's going to be like -1 times the square root of 16 plus 9. Okay, I've just replaced my x and my y. So then that's going to be -1 times, let's go ahead and finish our addition under the radical. In this case, we're treating that radical, that square root, kind of like grouping symbols. So we want to take care of 16 plus 9. Well, 16 plus 9 happens to be 25. Okay, so I want to go ahead and figure out what is the square root of 25. So remember, when we're talking square roots, we're talking what are the two identical factors that would give me a product of 25. Well, that would be 5 and 5. So we say the square root of 25 is one of those two identical factors. So the square root of 25 is just 5. And then we have to address this negative that was outside the radical symbol or outside the square root. And we just treat it like a -1. So at the end of all of this, we want to say -1 times 5, which is -5. So there you have it. We've gotten to practice a lot of our signs here. We looked at multiplication, division, subtraction, addition, absolute value, radicals. We've done a lot of practice here, and all of it was a little bit of algebra, which is really, really cool. Okay, so next up, we're going to look at applications with the order of operations.